Hello, everyone. Welcome to the first module of chemistry material for this Chemistry 1A class. We're going to talk about some introductory ideas related to the context of what chemistry is and how to go about understanding those things related to what we'll be looking at beyond that. So I want to start by just looking at why is chemistry important? Chemistry is important for a variety of reasons. Most of the things we deal with in life are chemistry. So from the food and things we drink, there's lots of chemistry involved there. Cleaning, washing our hands, we know that's very important now, right? Lots of chemistry there. When we get a bit further in the course, we might even talk about why that's so important. Electronic devices are based on chemistry, and then fueling our cars to get somewhere, chemistry as well. So most of the things that we do are based on chemistry, and our understanding of chemistry, by our I mean the human species, understanding of chemistry is how we're able to even have those things in the first place. As we continue to progress, create new things, understanding of chemistry will be very important for you for that reason. I'm not going to go into a lot of history right now. We'll come back in module 2 to get into some history a little bit. But this is showing an alchemist workshop from, it looks like around 1580. And this was, a time when they were doing some experimentation with matter and seeing what happens. We would not consider that to be kind of the way science is done now in terms of how that was approached. We've kind of moved into this period of thinking of things where it's science if it can be repeated by someone else, where with alchemy, a lot of it was about, okay, well, you have to have a pure soul, or you have to have a certain personality to do well at that. We are learning that, in some areas like teaching, that those things are important. But in the experiments you'll be doing in the lab, you should all be able to get very similar results, because we're manipulating matter at a level where it's not based on who we are. So that's a little bit about kind of where some of this came from in terms of where we're going to go about manipulating matter. And you think of these kinds of things with alchemy and the experiments we'll be doing in the lab as you think of that. We touched on this a little bit earlier when we mentioned, how important this is. But one way to view chemistry is what we call the central science, because it's so connected to all other areas of science. Most of you are not chemistry majors, I'm guessing, because usually that's the case. Most of you are going into all these other fields where chemistry will be very important. Actually, one of the things we'll be doing this semester, and I haven't done this before, is you'll be doing little presentations where you get to pick an area that might be more related to a direction you're going in. Instead of covering all that material, we're shortening it up a little bit, and then we get to hear those presentations of things that might normally be covered in some chemistry courses, but will not be on an exam. We just get to kind of hear about it from our peers. So I'm sure some of you are in some of these other fields, and hopefully you can see how your field relates to chemistry, and kind of specifically, as we go through the course, kind of see, well, this idea is very important for the career direction I'm looking at. And in some cases, maybe it won't be as important, but in many cases, it will be very important. And some things will be very important for all of these fields. So just be aware of that as we move forward in the course. I wanted to also touch briefly on the scientific method And we might use this as a way of understanding some of the material in Module 2. But the reason I want to do this is because there's often some misunderstandings about how it actually works. So we observe things about the world and we might have questions and curiosity and think, well, maybe it's happening for this reason, or maybe some other things are going on. And we can come up with what we call a hypothesis as sort of a very loose sort of explanation of, okay, this is maybe why that's happening. And maybe we leave it at that, or maybe we press further and do some experiments to show whether or not that's true. Um, from those experiments, we can make some observations and see, okay, does that fit the model I had with my hypothesis? Um, and this sounds very simple, but in reality, this could be an entire career, not just for one person, but for many people. So this is something over the course of several decades, several people doing this might lead to something that actually changes on a very fundamental level our understanding of nature. So that's kind of what we're showing here. So if they are consistent with the prediction, then we're contributing um, to the body of knowledge. But in some cases, the hypothesis is not supported um, by the results. So you have a hypothesis and it's completely wrong. That's valid. That's useful information. It doesn't mean you're a bad scientist because your hypothesis was incorrect. It means you learned something. So learning is important. A lot of what we do in science is being wrong, which is kind of counterintuitive. Um, but a lot of it is being wrong and then figuring out what to do with that and move forward. We try to make the experiments here so they're not that wrong, as wrong as often as they would be in the real world. We try to make them pretty straightforward. But in the context of creating new knowledge, it's often going to be very wrong. And over the course of several decades, somebody, if they're very lucky, very persistent, very intelligent, they will have a big contribution to our understanding of the world. So from that, there's basically two directions that can happen if those changes are happening. Those are laws and theories. And these are, I did want to talk about this a bit because these are very different in science than they are in everyday language in terms of how we use these words. So we use the word law in everyday speech to say the law says this, so that means we have to do it. Um, Whereas in science, a scientific law is saying this is just how it is. It's not that somebody's enforcing the speed of light. That's just the speed of light. Nobody's making sure the apples fall off the tree. They just do, right? It's the law. When we say scientific law, there's not nobody enforcing that law, right? It just is. And if it doesn't happen, then we have to rethink, well, why not? Maybe we have to change that law and state it differently because we know more about reality. And that has happened in the past 100 years for sure. Another thing that can happen is it can become a theory. So a theory is a different kind of thing than a law. So a law is saying this is what happens. This is just what happens, whereas a theory is an explanation for why it happens. So they're different in terms of, on this slide, the law is higher than the theory. In reality, they're not, like one is better than the other. They don't graduate from theories to laws. They're just different types of things. Laws are what happens. Theories are an explanation for why they happen. That's where these words are a little bit different because in kind of everyday language we use the word theory a little bit more loosely and maybe more like we would use the word hypothesis. But a theory that's a scientific theory has multiple strands of evidence from very different fields in order to reach that level of certitude that we would be willing to call it a scientific theory. And then the last thing I want to talk about in this section is the way we understand chemistry and how we represent chemistry when we talk about it. So there's basically three levels here that we can talk about. We have what we call the macroscopic domain. That sounds like a really big word, and it is kind of big. Macroscopic means big, and by big, we mean things that are our size, things that we can see with our eyes are macroscopic. We can observe things with our normal senses. And when we talk about things in chemistry, in that way, we're talking about their macroscopic properties. So we're looking here at an iceberg in water surrounded by water vapor. We'll talk in the next section about the physical states, but we can observe that, right? We can observe a liquid, we can observe a solid, we don't really observe a gas, but we kind of know it's there. Those are macroscopic properties. We can also talk about the molecular level. It's saying here microscopic domain. It's actually even smaller than microscopic. So either molecular level or microscopic are often used to describe that. And here we're looking at, well, if we zoom way into the very tiny particles that make up what's going on, what's actually happening? And we'll talk more about atoms in the next section, but that's what we're looking at here, right? So we're saying, okay, this is what's going on, this is what's going on, this is what's going on. We'll talk more about what's going on in the next section, but we're looking at maybe drawing pictures of atoms when we look at the microscopic domain. But most of the time, what we talk about in a chemistry course is not really either one of those. It's what we might call the symbolic domain or the formula domain. So we're using these symbols, H2O, parentheses G, to mean something. In this case, what that means, we're talking about water vapor, but it's not an alphabet soup. We're not saying that the way chemistry works is there's all these letters flying around and they do things. No, we have to understand that when we write these things down, what we mean is this stuff at the molecular level and this stuff at the macroscopic level. And part of what we'll be learning is, well, what is that look like as we go through the course? But we do this in part because we're not artists necessarily. We don't want to have to draw all of this every single time. So we have this shorthand notation to represent what's going on. So just kind of a little bit of a basis for, as we move forward, we're going to be doing a lot of this symbolic stuff to describe the molecular level stuff or the macroscopic level stuff that's going on. So just be aware of that as we move forward. So that's it for this first section. Feel free to move on to the next one.